So in today's lesson, we're going to talk about using scientific notation. Now, anytime we use scientific notation, this is something that you could use in algebra, something you'll use in science, and in your science classes, we've talked a little bit about, you'll hear about scientific notation. So a lot of times you guys have seen this in the past, and so that hopefully this is just kind of a review lesson for you. So scientific notation is just simply a method of writing a number as the product of a number greater than or equal to 1 but less than 10 and a power of 10. Now that sounds really confusing. It's not. Just kind of understand that when we talk about writing scientific notation, we always have, a number like 8.23 times 10 to the third power. This will be written in scientific notation, and so this is how you would write it out. Now keep in mind the decimal is always going to fall between the first significant digit and the second significant digit. But the significant digits have to be something other than 0. You can't have 0.23 times 10 to the fourth power. We can't have that because 0 is not considered a significant digit. It's got to be 1 or something else. So anytime, when we talked about it with the 8, it's got to be 8.23 times 10 to the third or whatever it may be. Now, when we talk about writing scientific notation, we can move the decimal left or right. So if I erase this here, anytime we move the decimal left, we're going to have a positive exponent. So anytime we move it left, we'll get a positive exponent. Anytime we move it right, we'll get a negative exponent. So those are just some things that you need to keep in mind. Those are the two biggest things with scientific notation when we write them, is understand that if we move right, it's a negative exponent. If we move the decimal left, it's a positive exponent. So let's take a look at example 1 here. We have 856,000, and we need to write this number in scientific notation. Now keep in mind, anytime we talk about this, your decimal is always out here to the far right. So again, we're moving it left, which means we'll get a positive exponent. So we're going to move it left 1, 2, 3, 4, 5. And so we have 8.56 times 10, and we moved it 1, 2, 3, 4, 5. So we moved it over 5 spots, so it's 8.56 times 10 to the 5th would be how you would write that number in scientific notation. So if we went and wrote another number, this time we have 0.0005, and we need to write this number in scientific notation. Again, we have the decimal in between two zeros, but those aren't significant digits, so we have to move the number over till we get a significant digit. So we're going to move it over 1, 2, 3, 4. Now we're after the 5, so it's going to be 5 times 10 to the, since we moved it to the right, it's going to be a negative exponent. 1, 2, 3, 4 would be a negative 4. So our number in scientific notation would be 5 times 10 to the negative fourth power. Now we talk about multiplying scientific notation. This is not going to be really all that difficult. It's just a matter of paying attention to what's going on. So let's look at example 2 here. We have 5.7 times 10 to the 5th power. And we're going to multiply that times 1.8 times 10 to the 3rd power. Now when we do this, all we're simply going to do is just multiply the two numbers together. So 5.7 times 1.8, and then we're going to multiply the 10 to the 5th times 10 to the 3rd. So when we multiply 5.7 times 1.8, we get 10.26 times 10, and since we have the 5 and the 3, we add those together to get 10 to the 8th. Now if you'll notice, we're not in scientific notation yet. It's got to be between the first significant digit, and here we're after two significant digits. So we need to move the decimal back to the left one spot, and again, we move it to the left, we go positive. So our number is actually going to be 1.026 times 10 to the 9th power. So this would be our final answer. Always remember, the decimal has to be between the first significant digit and the second significant digit. Now let's take a look at our last example. We have to find the quotient, and we need to write it in scientific notation. So 1.2 times 10 to the 3rd over 9.6 times 10 to the 6th power. Now again, we're going to look at this and say, how are we going to do this? So you're going to basically break this up into two parts here. So just like you would typically, so we'll divide the 1.2 and the 9.6. And when we divide those two, we get 0.125. and then we're going to have the times 10. Now remember, if we go back to when we talked about our exponents and dividing exponents, we're going to subtract. So 3 minus 6 would give us negative 3. Now again, you can see that we are not in scientific notation yet. We have to move the decimal over to the right one spot. So it's going to give us 1.25 times 10. And again, we moved it over to the right one spot, which means it's going to be another negative. So negative 3 plus a negative 1 is a negative 4. So our final answer would be 1.25 times 10 to the negative 4th power.